Hello, my little mathematicians. Today I'm going to help you do your 11.1 through 11.3 study guide. Now, before we go any further, I want to remind you that on the quiz, you're going to get 3 points taken off from whatever Canvas gives you if you don't show the inverse step. So what do you do to both sides to get your variable by itself? This may seem a little tedious because let me just show you really fast. I know a lot of them are simple like this, and you're like, I can just do this in my head. I know that x is 6. I know that you know that x is 6, okay? But eventually, they're going to get tougher like this next year with negatives and things on both sides. And a lot of you might think, like, what's that? Try and just guess. Okay, a lot of you might think it's 10, but if you check, 10 minus 2 is 8. Is 8 equal to negative 8? The answer is actually negative 6. And if you practice doing the inverse step, it'll actually be a lot easier. And then those of you that can do this in your head and you're like, I already knew that that was negative 6. Okay, eventually you're going to get to problems like this. Most of us can't just look at this and be like, oh, I know what k is. Okay, what do you think k is? It's 7. Okay, there's a lot of steps involved. So what we're practicing this year is those inverse steps that when you get to hard problems like this, the steps just become second nature and then you can solve these types of hard problems, okay? But we're going to start with easy ones that, yes, I understand you can do in your head, but we're mainly focusing on practicing the steps so that when they get hard like this, those steps will be really easy for you. Okay, now with that being said, look at where your variable is, and it's helpful if you draw a line down from your equal sign, so it kind of cuts them in half. And now here's where your variable is. You want to get it by itself, and this negative 15 is preventing it from being by itself. So what's the inverse of minus 15? Add 15. Now you can do that in order to make it cancel out and have x by itself, as long as you do the same thing to the other side. Okay, because think of it kind of like a balance. And when the equation first started, it wasn't balanced. But if you do something to one side, it's unbalanced. As long as you do the same thing to the other, it brings it back to being in balance. Okay, so as long as you do something to both sides, you can do whatever you want in order to get that variable by itself. I think we've killed it. Now let's just go ahead and actually do it. Okay, so you have 8, that's 38. I know it's simple now, but checking is just a good habit to get into in case you make a simple error. Hopefully you can catch yourself. So you think x is 38, so you're going to substitute in 38 for x, and then just double check it makes a true statement. So then type in 38 minus 15, and what do you get? You get 23. Bring down your equals 23. Is that a true statement? Yes, it is. So then with certainty, you know 38 was the right answer, and that's what you would put in the answer column. Okay, and then if it asks you to graph it, what's your actual answer? Is your answer 23? No, your answer is 38. That's what x is. So 38 is what you graph, and you just put a dot on a number line showing that that's your answer, and then maybe put one number bigger and one number smaller, showing that you know how a number line works. Okay, for number 2, what's preventing the x from being by itself? The 7. What's happening with the 7 and the x? They're being multiplied. What's the inverse of multiplying? Dividing. So if I divide by 7, these cancel because anything divided by itself is 1. 7 divided by itself is 1, and 1 times x is x. I got x by itself. Okay, and then whatever you do to one side, you have to do to the other. Okay, so then 28 divided by 7 is 4. All right, so the answer is 4. Now go ahead and check that. You have 7x equals 28. So 7 times what is 28? You think x is 4. So let's substitute that in. 7 times 4 is 28. Bring down the equals 28. Yes, that is a true statement. So 4 was indeed the right answer. That's what you'd put in the answer column. And then if it asked you to graph, that's where you'd put your dot on the number line, was at 4. Okay, same thing, except now we just don't have to graph it anymore. All right, how do you get h by itself? What's preventing it? This 15, what's the inverse of adding 15? To subtract 15. Whatever you do to one side, you got to do to the other. Now those cancel because 15 minus 15 is 0. So now h plus 0 is just h. And on the right side, 16 minus 15 is 1. Okay, don't forget to always check. H plus 15 equals 16. You think h is 1. Plus 15 equals 16. Simplify that. 1 plus 15 is 16. Bring down the equals 16. Perfect. It was a true statement. So 1 was indeed the right answer. And if you think this is lame, how many times do you kick yourself when you get a quiz back and you're like, oh my gosh, one of the most common mistakes, 2 plus 3, you accidentally put 6. And you're like, no, I knew that 2 plus 3 was 5. I just did it wrong. Okay, well, hopefully when you go to check your answer, you'll catch any simple mistakes like that. Okay, that's why we check. Make sure you get a true statement. If it didn't end with a true statement, like let's say you accidentally added these and you got 21, when you went to go, or actually if you added them, you would have gotten 31. And then you go to plug it in, you go 31 plus 15. Well, that's not equal to 16. So you would have erased this and been like, oh yeah, the answer was just 1. Okay, that's why we check, to make sure that this is indeed the right answer. Okay, number 4. What's preventing the y from being by itself? The 14. What's happening with the 14 and the y? They're being multiplied. And what's the inverse of multiplying? Dividing. Whatever you do to one side, you got to do to the other. How did that help us? Because 14 divided by 14 is 1, so now you have 1 times y, or just y. And then when you divide this side, 24 divided by 14 is 16. Okay, and then go ahead and check. You have 14y equals 224. You think that y was 16. So when you type that into your calculator, 14 times 16, you get 224. Bring down the other side. Yep, 224 is equal to 224. So that was indeed the right answer. All right, next one. What's preventing e from being by itself? That divided by 6. Now, I like to rewrite them like that, especially when we start having fractions. It just makes it easier. So you have e divided by 6, and the inverse of dividing is to multiply by that. Whatever you do to one side, you got to do to the other. Now those cross cancel and become 1, right? 6 divided by 6 is 1. So now you have 1 times e, which is just e. Perfect. I isolated this side. So now I just simplify the right. 24 times 6, you get 144. If you just want to double check that you got that right, let's see. Okay, so I'm going to plug that back in. E divided by 6 equals 24. You thought E was 144. Plug that into your calculator. 144 divided by 6 is 24. Bring down the equals 24. Yep, true statement. So 144 was indeed your right answer. Okay, this one's already set up nicely. It's saying E divided by 4. The inverse of dividing is to multiply. Whatever you do to one side, do to the other. Those cancel out and become 1. 1 times E is E. And 12 times 4 is 48. Okay, always check. E divided by 4 equals 12. Substitute in what you think E is. You think it's 48. And 48 divided by 4 is 12. Bring down your equals 12. Perfect, true statements. You know that 48 was the right answer. Okay, as always, you should always be trying these first. Pause the video, try it yourself, and then unpause it and come back to check. Okay, number 7, these are being multiplied. So the inverse of multiplying is to divide. And when you divide by a fraction, that's the same thing as multiplying by the reciprocal, where you flip it. If you're like, what does that mean? Okay, so let's say you have 8 divided by 2, right? Okay, and let's say that this was, actually, let's say 1/2 instead. Okay, so it's a fraction. So when you're dividing with fractions, you keep the first one the same, so 8 over 1. You change division to multiplication, and then you flip that second fraction. Remember that? Ringing a bell? Okay, so if you're dividing by a fraction, that's the same thing as multiplying by the reciprocal of that fraction. Okay, and the first one just stayed the same. So essentially, that's what we're doing here. We're keeping this the same, but we're multiplying it by its reciprocal. Okay, so then those cross cancel. These become 1, the 3's become 1, and 1 times x is just x. But whatever you do to one side, you have to do to the other. So since I multiplied this side by 8 over 3, I need to multiply this side by 8 over 3. You can simplify that. You could just multiply across 24 times 8 over 3 and then reduce it later, but I think it's easier to cross cancel at the beginning, smaller numbers. 3 can go into both of these. 3 divided by 3 is 1. 24 divided by 3 is 8. So now just multiply across. 8 times 8 is 64. 1 times 1 is 1. So you just get 64. Perfect. Okay, let's just double check this. 3/8 times x, and we think x is 64, equals, you think, 24. Okay, let's simplify. That's 1 and 8. 3 times 8 is 24 over 1, so just 24 equals 24. Perfect, true statement. So 64 was indeed my right answer. Okay, so think of how we did that one. How would you do this one? Well, these are being multiplied, so the inverse of multiplying is to divide. And when you divide with a fraction, that's multiplying by the reciprocal. So the inverse or reciprocal of 1 over 2 is 2 over 1. Those cross cancel. Those are already 1. So 1 times y is just y. But whatever you do to one side, you have to do to the other. So I need to multiply this side by 2 over 1, or 2, as well. And 6 times 2 is 12. If you were to check, half y equals 6, and you think y is 12, half of 12 is 6, equals 6. Perfect, true statement. So 12 is what you would write in the answer column. Okay, so those were all one step. Now we're going to do a two-step. What do you think you should undo first? Multiplying or dividing? Or sorry, multiplying or adding? Okay, since we're doing inverse steps, you do GEMDAS or PEMDAS in reverse order. So I know that normally we do multiplication or division before we do addition or subtraction, but when you're doing the inverse steps or the undoing steps, you need to do it in inverse order. So I'm going to do addition or subtraction first. So how do I get rid of this adding? I'm going to subtract it. And whatever you do to one side, you got to do the other. Okay, 58 minus 58 is gone. I just have 3r left. And when you simplify this, 94 minus 58, you get 36. Okay, now you still have r isn't by itself. That 3 is preventing it. And they're being multiplied, so the inverse of multiplying is to divide. Okay, 3 divided by 3 is 1, and 1 times r is r. And on the right side, 36 divided by 3 is 12. Okay, let's just double check that we got that right. 3r plus 58 equals 94. We think r is 12. So 3 times 12 is 36. And 36 plus 58, type that in, and you get 94. Bring down your equals 94. Perfect, true statement. 12 was the right answer. Okay, now for this one, there's two things you could do first. Okay, you could do inside the parentheses first, simplify the top, or when there's these, you could get rid of the bottom and you could multiply both sides by whatever that denominator is so that they cancel on this side, and now you're just left with whatever the numerator is. Okay, and then I can simplify inside of here. 3 plus 2 is 5. Z equals 40. And to get z by itself, I'm going to divide by 5, and z equals 8. Okay, instead of checking, I'm going to show you another way that we could have done this. Okay. Some people like to get rid of this denominator first, so they multiply by whatever's down there to get it to cancel. Okay, but you could have done parentheses first, And then technically you have 5/10 z, and 5/10 can reduce to 1/2 z. And then you're like, oh, well, these are being multiplied, so I can multiply by the inverse of 1/2, which is 2/1, or just 2. And those cancel. You just have z equals 4 times 2 is 8. Okay, it's just a matter of preference of which way you like better. Number 11, okay? These ones say determine which equation has a solution of h equals 10. So essentially what you're doing is it's that somebody said, oh, I solved this equation. Can you just check it for me and make sure that 10 was the right answer? And I strongly recommend that you don't solve the equation yourself and make sure that it's 10, but instead you substitute 10 in and simplify it and see if it makes a true statement. Because sometimes if you try solving it, if it's set up wrong, like for instance, if your variable is negative or if your variable is in the denominator, it might be harder to solve for you versus you could just check it for them. Okay, so let's see. Plug 10 in anytime you see an H. So there, and there. Okay, and bring everything else down. Divided by 8 equals 80. 8 times that 10 equals 80. 10 equals 1 divided by that 10, or 11 minus 10 equals 21. Okay, so see how these equations are exactly like how they started? I just replaced the h with a 10. I'm checking it for them. Okay, 10 divided by 8. Okay, well, if you type that into your calculator, you get a decimal, okay, or just think about it, you have 5/4. Is 5/4 the same thing as 80? No way. Okay, so that one doesn't work. 8 times 10 is 80. Bring down your equals 80. True statement. So B would work with 10 being your solution. 10 equals, this is not saying 10 divided by 1, it's 1 divided by 10. And this is why I like writing them as fractions rather than this way, because isn't it easier to see that this is not equal to this? This is just 1/10. You can't reduce that anymore. Not the same thing. But if you wrote it this way, you might be tempted to put, oh yeah, they're both 10. But it's not saying 10 divided by 1. It's 1 divided by 10, which is 1/10. Okay, 11 minus 10 is 1, which is not equal to 21. So the only one that worked was B. Okay, always double check if it says select all that apply, because sometimes there's more than one that will work. So even though you got one, you'd want to double check. That was tricky that they actually only had one answer though. Okay, the next one is the same thing, except this time you're going to do it for 6. So if you didn't try the other ones, try these ones first. Pause it and then come back and check. Okay, so you're back with us. You substituted in 6 every time that you saw an X. And let's see which one of these work. 6 divided by 6 is 1. True statement, so that works. 7 minus 6 is 1. True statement there, so that one works. 6 divided by 6 is 1, so that one works. And 2 times 6 is 12. 1 plus 12 is 13. And bring down your 27. Not a true statement, so D didn't work. All of them worked except for D. Hopefully you got those right. And now you're ready to move on to writing an equation from a word problem. Okay. Definitely pause the video, try to write an equation, and then come back with us and check. Okay. Number 13 says Drew's pet cat lost 4.3 pounds last month and is now 9.55 pounds. How much did Drew's cat weigh? That's what we're trying to figure out. Write an equation using X to represent the original weight. So it started out at some weight, we don't know. Then it lost 4.3 pounds and is now 9.55. Okay, to me, that's the one that makes the most sense. But you could have switched it where if it started this and you subtract how much it is now that will tell you how much it lost. Okay, these are saying the same thing. Now, there's usually about 4 ways to write an equation. There's that, or then there's the inverse of them. So the inverse of subtraction is addition. So you could have done the starting weight is equal to how much it lost plus how much it is now. Or same thing, how much it is now plus how much it lost is equal to how much it started with. Okay, any of these would be fine. And of course, if we switch sides and you had 4 plus 3 plus 9.55 equals x, it's the same thing. Okay, number 14 says Sophie's pet dog weighed 7.24 kilograms last year and now weighs 5.8 kilograms. How much weight did her dog lose? Okay, again, if you're not trying these first, like pause it, try it yourself, then unpause it and come back. Okay, so it started at 7.24. Then it lost some amount of weight that we don't know, and now it's 5.8. Okay, or you could say it started as this. If you subtract what it is now, that'll tell you how much it lost. Okay, same thing. Or you could do the inverse, which would be what's the total? Okay, so it would be how much it weighed is equal to how much it is now plus how much it lost. Okay, and then finally, just if you switch these. So everything's the same except I just switched where these are x plus 5.8. And those are the 4 different equations you could have. Obviously, you only need one. I'm just showing you the different possibilities that it could have been. Okay, number 15 says Hare sold 32 bags of popcorn over the weekend, and each bag was sold for $6. What is the total amount of money that he earned selling popcorn? Write an equation using x to represent the total money that he earned selling popcorn. Okay. So normally it's you take how many you sold times how much each one was, and that's equal to the total, which we don't know the total. There you go. Obviously, you could switch them. 6 times 32 equals x, same thing. Okay, and then for division, you could take the total and divide it by how much each one is set that equal to how many bags he sold, or switch that. The total divided by how many bags he sold is equal to how much each one was. Okay, those are the different equations. It's just a matter of opinion of which one you think makes the most sense to you. Okay, number 16. A store sells all items for $3. On Monday, they earned this much. How many items did the store sell? Okay, so what do you think? Okay, well, normally it's how many items you sold times how much each one is equal to your total. There you go. Technically, you could switch it. X times 3 equals 2,844, but we like the number in front of the variable. And then the inverse of that is you could do the division way, which, what is that? It would be the total that you earned divided by how much each one is equal to how many you sold. Okay, or technically you could do the total divided by how many sold is equal to how much each one was. Yes, this one works, but we want to avoid having your variable be in the denominator if possible, because it just makes solving it harder because you'd have to get it out of there. And we'll show you how to do that later. But I would avoid having your equation contain your variable in the denominator if possible. Also, I'd avoid having your variable be negative if possible, because it just makes solving it harder. Okay, Number 17. These ones, they just wanted me to write the equation. But now it wants me to write the equation and then solve it. Okay? So it says Jamie gained 12 pounds and is now 106 pounds. How much did he weigh before? Okay, so do we know his starting weight? No. But we know that he gained, which means, does that add or subtract? He added 12 pounds of that weight, and now he is 106. Okay, that's the way that makes the most sense to me. Some people maybe switched these two is equal to how much he is now. Or, of course, you could have subtracted and said his original weight is equal to what he is now minus the weight that he gained. Okay, potato, potato. Okay, now to solve it, I probably would have done this one. And then to get x by itself, you would subtract 12 from both sides. And what do you get? 106 minus 12 is 94. So that means that originally he weighed 94 pounds. And then kind of double check to make sure it makes sense. Okay, he was 94 pounds when he started. He added 12 pounds, and then that's equal to 106 pounds now. Okay, double check that in your calculator, and yep, that makes sense. Okay, number 18 says Mason cut 8 inches of fabric off from a roll. There's now only 22 inches of fabric left. Write an equation to represent how long the fabric was before he cut it. So you have your original amount that we don't know. He cut away 8 inches, and that's equal to how long it is now. To me, that one makes the most sense. That's how I would solve it. So to get x by itself, what's the inverse of subtracting? You would add 8 to both sides. Okay, and then you get x equals 30. Okay, double check that makes sense. If it starts at 30 and then you cut 8 away from it, yeah, you have 22 left. Makes perfect sense. Those of you that maybe solved it differently, you instead might have done what it started with minus what it equals is now is equal to how much you cut away. Sure. Okay, or the original amount is equal to how much was cut away plus what it is now. Sure, that one works as well. Okay, no matter what, any of these you would have solved, that simplifies to x equals 30. This one you would have added 22 to both sides and you would have gotten x equals 30. So no matter which equation you would have solved for, you still would have gotten that it was originally 30 inches long. Okay, number 19 says Marley bikes at a pace of 9 miles per hour. How many miles did she travel if she biked for 3 hours? Write an equation using x to represent the distance Marley traveled. Okay. If it's hard to figure out what to do, it might be easier if you make yourself a little table. So you have the number of hours you've been biking and how many miles you've gone. And the rate tells me that you went 9 miles in 1 hour. So then if you go 2 miles, how far have you gone? 18 miles, right? So what's the pattern? If you take the number of hours and multiply that by 9, you get the number of miles, right? Okay, or you could say if you take the number of miles and divide it by 9, you get the number of hours. Okay, because if you do this, 1 times 9 is 9, 2 times 9 is 18. Or going this way, 9 divided by 9 is 1, 18 divided by 9 is 2. So the miles divided by 9 equals the hours. The hours times 9 equals the miles. Okay, well, what did they give you? They told me that she biked for 3 hours. So I'm going to plug in 3 for hours. Okay. So either one of those equations would have worked. It's just whichever way you prefer to go. Okay, so now either equation, those would be your answer. Go ahead and solve it. 3 times 9 is 27 equals m. So after 3 hours, they would have gone 27 miles. Okay, or if you set up this equation to solve it, how do you get m by itself? We'll multiply by 9. And m equals 27. Okay, again, using a table to help you set up the equation for multiplying or dividing equations is really helpful. Okay, the next one or last one says Wanda sells boxes of cookies for $5 per box. Yesterday, she earned $70. How many boxes of cookies did she sell? Okay, so how much is each cookie or each box of cookies? It's $5 times how many did she sell? We don't know. And that's equal to the total amount of money you make, which is 70. Okay, to me, that way makes the most sense, but maybe some of you guys did the total divided by how much each one equals how many she sold. Or the total divided by how many she sold equals how much each one is. Yes, this one would work, but I would avoid it because you don't want to solve it with x in the denominator. Okay, but either of these are fine. If you did this one, 70 divided by 5 is 14. Bring down your equals x. There you go. She sold 14 boxes. If you use this equation, how do you get x divided or x by itself? Divide both sides by 5 because 5 divided by 5 is 1. So you have 1x equals, and 70 divided by 5 is 14. So no matter which equation you use, this one or this one, you got that she sold 14 boxes. And then any of these equations are good and would work. However, I would avoid using this one, again, because we don't want to have x in the denominator. Okay, my little mathematicians, I hope you did really good on this. If not, there's plenty of extra practice pages in our packet that you can try that are similar to ones that you missed. And again, if you had any difficulty setting up equations with multiplying or dividing relationships, I suggest using a table to help you write it. That would be pretty helpful. All right, you got this.